All right, so we've already talked about special right triangles once before, one of the cases, which were isosceles right triangles. We have another case to talk about, which is when we draw altitudes and equilateral triangles. So let's review isosceles right triangles. And that just means that I've got a right triangle, obviously, because it says right triangle. So it's going to have a right angle in it, and isosceles means my two legs are going to be congruent to one another. And what we talked about before is that when we draw these out, these are called 45, 45, 90s. Remember, because if they're isosceles and right, those other two angles must be 45. And the pattern on the outside, we figured out, well, if one of the legs, we don't know, if we call it x, well, since it's isosceles, the other leg is going to be x. And then if we work out Pythagorean theorem, it's going to give us the last side ends up being in a ratio of x square root 2. Now, altitudes in equilateral triangles give us a different ratio. So on these, what I'm going to do, I'm going to start by drawing an equilateral triangle. Hopefully, that's what I'll draw. All right, and an equilateral triangle, I know that all of these inside angles are going to be 60. So I'm just going to draw one. When I draw an altitude, what we've talked about earlier this week, I don't know if you remember, altitude is when we draw a side or a length that's perpendicular on the inside. So I'm going to drop, they call this dropping an altitude, right? I'm going to drop this altitude in the middle, and that's going to create this right angle right here. Now, not only does that make, so we know this bottom angle is going to be 60 degrees. When I drop that altitude, it's going to do two things. One, it's going to cut this bottom piece in half into two equal pieces. And two, it's going to cut this top angle in half. So this top angle is going to become 30 degrees. And then think about that. If this bottom is cut in half, well, originally, this bottom length and all the sides really were all congruent to each other. So now if it's cut in half, it's half of the other side. So I'm going to start by calling this smallest side x. And I am looking specifically, now we're really just talking about the relationship between this small triangle. We call this a 30, 60, 90. Okay? I call this smallest side x, and that means the hypotenuse is going to be 2x. Because remember, those side lengths originally were all the same. Now, if we set up Pythagorean theorem, we can figure out what the relationship is between this other leg. All right, so if I do that, I'm going to set up x squared plus, I don't know the other leg, I can call it, I don't know, y squared, equals 2x squared. If I work that out, that's just x squared plus y squared equals 4x squared. Now, I want to solve for y, because remember, y is standing for this other leg in my problem. So I'm going to subtract an x squared from both sides. And that's going to give me y squared equals 3x squared. Now, I've almost got y by itself, but you all know the last step anytime we're doing Pythagorean theorem is to take the square root, which is going to give me y equals the square root of 3. And actually, that x out there, that x squared, when you take the square root, it's going to make a whole x. So I'm actually going to write that as x square root 3. Because when I take the square root of x squared, it just gives me a whole number x. Square root of 3 is just the square root of 3. That means this last leg is in ratio of x square root 3. So that's the ratio that you need to know. For 30, 60, 90s, they're in ratio of x, 2x on the hypotenuse, and x square root 3. All right, so let's look at what this looks like for a problem like this on the 30, 60, 90. All right, so if I solve here, I'm going to go ahead and write my ratios on the outside. And I know from what we just said, the small side is x, the hypotenuse is 2x, and the altitude, or this other leg, is going to be x square root 3. So wherever I have a number and a ratio, that's going to be the equation I can start with. So if I start with this equation, that means x square root 3 equals 12. And I want to figure out what x is. So I'm going to divide by the square root of 3. And you all know we're not allowed to keep square roots on the bottom. So I've got 12 over square root of 3. I'm going to do what we call rationalize that and put another square root 3 down there. So if I've got square root 3 down there, those on the bottom, square root 3 and square root 3 are going to end up making a whole number 3. So this is going to be x equals 12 square root 3 over whole number 3. This is just a review from algebra right now, right? And then 12 and 3 are both whole numbers, so I can simplify those. Both of those divide by 3, so I can divide both of them by 3. And that's going to give me that x equals 4 square root 3, because 3 divided by 3 is just 1 on the bottom. So now this is going to help me find my other pieces. So I know x is going to be 4 square root 3. So I'll write that out. That one's 4 square root 3. And then this other side is twice that, which means this hypotenuse is going to be 8 square root 3. Or you could set that up, if you don't see where I'm getting that, 2 times 4 square root 3, which is 8 square root 3. All right, so just like we did before, you're just going to label the ratios on the sides, solve for the variable you're missing, and then use that to find the other side lengths.